We've made it to week 4. We're halfway through the course, and we've covered a ton of material so far, and now we're deep into the post-production process looking at mixing, and specifically this week, we're going to be looking at dynamics, and specifically how we can actually control the levels of our tracks dynamically over the course of a song. It can be done manually by controlling automation on volume faders, or we can use plugins designed specifically for controlling the dynamics of a track. Those would be your compressors, your limiters, expanders, and gates, and we'll get deep into those this week. But before we get to that, I'd like to talk about just dynamics in general. We're going to be using this term dynamics all the time over this lesson, and it's just like any other of those terms in music, in that depending on the context, it can have kind of different meanings. So I'd like to just talk about the different meanings dynamics can have. To a performer, dynamics is going to be kind of the musical control of volume over the course of a song. And even if you look at a musical score, the dynamic markings in a score are the things like piano and forte and the hairpin indications, and they're really indicating to the musician how to perform those variations. Now, the interesting thing about musical dynamics in that instance is it's not just volume that changes. It's kind of the intensity of the performance. And you find that as you play harder, it gets brighter, the timbre change gets more aggressive, right? So dynamics in that instance is more than volume. It's really an instruction to the performer to get more intense, and it does change more than just volume. If we're talking about musical equipment, like microphones and noise gates and compressors and EQs, well, they're going to have a dynamic range, which is the range in levels that can come into it and go out of it that it reproduces accurately. And in that instance, there's a range, a dynamic range, where it will reproduce the sound properly. Outside of that range, you're going to have some issues. And the bounds of that range on the bottom end will be your noise or your noise floor, and on the top end is going to be kind of a ceiling when it starts distorting. We call this range, this dynamic range, kind of the linear area, the range where it will reproduce the sound accurately, and outside of that we're going to have issues. So in this lesson we're going to look at the specifics of the noise floor and of distortion. And we'll look at kind of both musical uses and how we can kind of avoid both of those things. Now, the human ear has a dynamic range also, but it's kind of complicated because our perception inside the dynamic range is kind of changing all the time. In that, have you ever noticed that if you're in a quiet room, you start noticing the little sounds maybe you didn't hear before? And then if you're in a loud space, you have no problem. You hear everything, you hear the loud stuff, maybe the quiet stuff is gone, but you're still able to hear what's going on. We kind of have this automatic gain control. When things get real quiet, our brain kind of lifts up the volume automatically. And when things get really loud, it kind of brings it down. And that's great in day-to-day life. It allows us to kind of, adapt to the situation we're in, and we use that as a way to kind of locate ourselves, even if we're not seeing what's around us. But in a mixing context, when we start getting into music production, that natural perception kind of fights against us, because we don't have a set absolute level for amplitude or for volume, for loudness. Instead, we have this kind of shifting scale all the time. So like we saw with frequency, I said it was nice to have a spectrum analyzer so that we can start associating the sound with specific numbers and hertz. Well, with amplitude, it's also nice to start relating what you're hearing to specific numbers. And amplitude, or loudness, is measured in decibels. And if we're in the air, if we're talking about sound in the air, we tend to measure it with dBSPL, or decibels sound pressure level. Now, the decibel scale is a logarithmic scale, and honestly, it's kind of hard to understand, and I would suggest that you take some time to search on the web or talk to your classmates here in this course about decibels in general. Decibels is always a relationship. It's kind of a ratio to a set point, and it can be used in a variety of contexts. So we need to always kind of qualify, when you say decibel, what kind of decibel. And you'll notice when I'm saying decibel SPL, or sound pressure level. And what that sound pressure level does is it gives us an absolute reference point for the decibels. And in this instance, the dBSPL, the reference point, is the threshold of hearing. It's the quietest thing. So 0 dBSPL is actually the quietest thing we can possibly hear as human beings. And if we go up from that, the kind of max range is our threshold of pain. I'm sure you've been in a situation where something's so loud it starts hurting. Well, that's going to be the kind of upper range. So we can say our dynamic range, the dynamic range of the human ear, is going to be from the threshold of hearing, 0 dB SPL, up to the threshold of pain. And that's in the range of 120 to 140 dB SPL, depending on the study and who you're talking to. And the thing is, loudness, as we saw, is kind of a complicated thing in that duration matters, and there's a lot of factors in it. But that gives you a kind of a good range of kind of what the human being can kind of hear. And we're always kind of shifting our focus inside of that. So because we're kind of shifting all the time, because we have this kind of automatic gain control, I think it's really useful to have some kind of absolute. And to be able to get that, I would suggest getting a sound pressure level meter and kind of walking around with it for a while. And the great thing about these smartphones, like you see over here, we can get a sound pressure level meter just for it. And I would suggest just walking around your daily life and just getting a feel for the general levels. I know when I started doing this, I was surprised to see some things. Like when I was in a quiet room, it would be still registering like 30 decibels, which was kind of strange. Let's see it. So we start noticing the noise of my computer, the fan noise of my computer, maybe the air conditioning, all these things. And did you notice, like when you do that, everything starts to seem to get loud. You start noticing all those really quiet things. And then the other thing I was surprised to notice was when I was on the train on my morning commute, it was at or over 100 decibels the whole time. That's pretty close to the threshold of pain. And then I'd look around and see people with earbuds in, right? Going even above that, trying to compete with that noise. That's dangerous, but we don't notice because we're constantly adjusting our level kind of automatically. So getting a good sense of the decibel scale with a meter is a great idea. Something on your smartphone or just a real meter is a great idea. Also, when mixing, try putting it in front of you near your studio monitors. It's really effective to mix at the same level over and over and over. Because if you took a chance to study the equal loudness contours, the Fletcher-Munson curves, if you study those, you'll actually find that our EQ, our kind of built-in frequency response of our ears, changes with amplitude. When things get quiet, we notice the mid-range more and more and more, and the bottom and high end kind of drop off. And when things get louder, up to around 80-something decibels, it flattens out a bit, and above that it gets, painful. So if you're changing the levels of your monitoring all the time, you're actually not getting an accurate representation of the music. The frequency response is changing the whole time. So having that SPL meter out when mixing and just being consistent every day about that will give you a much better sense of your mix, and you might have less of those issues. I know I've often, before I started being aware of this, I would mix one day, maybe just at a level I wouldn't really be thinking about it, turn the monitors up, I'd love how it sounded, and I'd come back the next day and just turn on my system and listen, and I'd think, oh, this thing sounds totally different. What was I thinking? And a large part of that was just that my monitors were at a different level. And that changes how everything sounds. So something to be aware of and kind of consider. So over the course of this lesson, we're going to look at some more of the specifics of dynamics, particularly noise floor and then distortion. We'll look at the corrective uses, how we can avoid noise, how we avoid distortion, and then also some of the creative uses, why we might want to use distortion and why noise can actually be a creative thing. And then we'll look at ways of manipulating dynamic range over the course of a tune. Manual ways, like writing in a fader to correct a vocal or a bass part. And then we'll look at kind of automatic gain controls, things like compressors, limiters, expanders, and gates.